or sorry, 2 by 8 by 4. Now if you multiply that out, you get 112. And if we take our new volume, 112, we divide it by the original volume of 252, you'll get, if you reduce it, a volume scale factor of 8/27. And again, that would be 2/3 cubed equals 8/27. Okay? So this page is kind of a recap of what we've talked about already. Linear scale factor in ratio form A to B or A/B. I kind of prefer A/B. This ratio describes an enlargement or a reduction in one dimension and can be calculated using new length over original length. So again, if you have a new length that's greater than the original length, your scale factor should be a bigger number divided by a smaller number, so it's an enlargement. Perimeter scale factor in the ratio in the form C to D or C/D. This ratio describes how many times to enlarge or reduce the perimeter of a figure. Perimeter scale factor can be calculated using new perimeter over original perimeter, or perimeter scale factor is the same as linear scale factor. Area scale factor is a ratio in the form E to F or E/F. These letters don't really mean anything. They're just using to substitute in place of an unknown. This ratio describes how many times to enlarge or reduce the area of a two-dimensional figure. Area scale factor can be calculated using new area divided by original area, or area scale factor equals linear scale factor squared. So again, why is it squared if we're talking about area scale factor? And that's because area works in two dimensions. So you have to square the linear scale factor. Surface area scale factor is linear scale factor squared. So surface area scale factor is the same as area scale factor. Volume scale factor, if we kind of cut through all this wording here, volume scale factor works out to linear scale factor cubed. And why do you have to cube it? Well, if you remember, volume works in 3 dimensions. Okay, so you have to cube the linear scale factor because each one of the scale factors, linear scale factors, is getting enlarged as well, or reduced. Okay, the scale factor relationships. Perimeter scale factor equals linear scale factor. Area scale factor is linear scale factor squared. And volume scale factor equals linear scale factor cubed because it works in 3 dimensions. Alright, here's an example. Axis Globe Limited produces globes with a diameter of 30 centimeters. You can draw that in your book if you want. A diameter of 30 centimeters. Okay. Isabel, the manager of Axis, has her employees construct a globe with a diameter of 1.5 meters to put on the roof of their building. The surface area and volume calculation of the globes with a diameter of 30 centimeters are shown below. Complete the work below to calculate the surface area to the nearest 0.1 centimeter squared and the volume to the nearest 0.1 centimeter squared of the globe with a diameter of 1.5 meters. Okay, so the radius of a globe with 1.5 meters is going to be 75% because that's just divided by 2. That's how you get that. Alright, so surface area of a 30 centimeter globe is 4 pi r squared. 4 pi times the radius of the original globe. So radius of the original globe is 15 centimeters squared. So you plug in 15 centimeters here. And we work that out to be 2,827 centimeters squared. Now we're going to do the surface area of an actual globe. Alright, because this is a big one that's going on the roof of the building, so it's 1.5 meters. So 4 pi r squared is the formula for surface area of a sphere. So we have 4 pi. What was the radius of the globe that's going on the roof? Well, it's 75 centimeters, so we plug in 75 centimeters. And if you punch that into your calculator, 4 times pi times 75, you should get 70,685.8 centimeters squared. All right. Now we're on to the volume of the 30 centimeter globe. So this is the small globe. So 4 over 3 pi r cubed is the formula for volume of a sphere. So again, we plug in our 15 centimeters from the model. And if you multiply that out, you get 14,137.2 centimeters cubed because we're working with volume. So let's do surface area, volume of the big globe. So this is the 1.5 meter globe. Okay? So again, we start out with our pi r cubed, formula for surface volume of a sphere, which is 4 over 3 pi r cubed, and get 4 over 3 pi r, in this case is going to be 75 centimeters, and we cube that. And if you do that in your calculator, you should get this big number, 7145.9 centimeters cubed because we're working with volume. All right, use your above results to determine to the nearest whole number the following scale factors from the 30 centimeter globe to the 1.5 meter globe. So the linear scale factor, you have to take the new dimension, which would be 150 centimeters. That's the diameter of the actual big globe that is on the roof, and divide it by the original, which the model is 30 centimeters. So if you reduce this, you have a scale factor of 5, which means the sphere that's going on the roof is 5 times as big as the model. Now the surface area scale factor, you need to square it, but we can also use the new surface area, which is 70,685.9 divided by the original, which was 2827.4. And if we reduce that, we get a surface area scale factor of 25. And the last one, the volume scale factor, we're going to use the new volume, which is 176,7145.9 centimeters cubed, over top of the original, which is 14137.2 centimeters cubed. And if we reduce that, we get a volume scale factor of 125. Okay. Show how to use the volume scale factor to determine the linear scale factor. So remember how you take the linear scale factor and you cube it. So linear cubed equals volume scale factor. So the reverse holds true. If we take the volume scale factor and we take the cube root of it, volume scale factor, we should get what the linear scale factor is. So if the volume scale factor is 125 and we take the cube root of it, we'll get a linear scale factor of 5, which when we did our calculations, just from using the linear scale factor, we got 5 as well. So it's the same. That's good. Show how to use the volume scale factor to determine the area scale factor. Well, we just take, if you remember, the linear scale factor squared equals the area scale factor. So we're going to take the linear scale factor that we found using the volume, and we're going to square it. So 5 squared equals 25. And that's the same as what we found here. okay? So originally the linear scale factor, we took the new diameter of 150 centimeters, divided it by the old, or the original, of 30, and we got a linear scale factor of 5, which means the linear dimensions are 5 times as big. So if you took the diameter and stretched it out 5 times as big, you would get the new diameter. If we squared the linear scale factor, we should get the surface area scale factor, and if we cube the linear scale factor, we should get the volume scale factor, and that's what worked out here, 5 and 25. All right, if a question asks for the scale factor of enlargement or reduction, it is implied that the linear scale factor is required. So if they want the surface area or the volume scale factor, they will say surface area or volume scale factor.